Welcome back to 15th Street Automotive. We've got a 2012 Chevy Silverado 6.6 Duramax check engine light. We're gonna scan this thing and figure out what the heck's wrong with it. Alright, the codes we have in here are a P20B9 reductant heater control circuit, and then a 2610 control module ignition off timer performance. I believe our problem that we have to deal with is the reductant heater control circuit. Let me show you on the dash here. We have our reductant light flashing there, and then we have here, it says 70 miles until 4 miles per hour max speed, service exhaust fluid system. So that's likely our code that we have to go after. So he's already been limited to 55. Probably the reason why he came in for can't go over 55. So let's go into the reductant heater system and see what's going on there. Okay, so our reductant level is 100%. Alright, looking here in all data, our code is a P20B9 reductant heater 1 control circuit. So our P20B9, I don't know why this is cut off here. I don't have a bar to change it. Is a short to voltage on our tank heater control. So conditions for running a B9 reductant heaters commanded on. Glow plug control is less than 254 degrees. Glow plug control module battery voltage is good, and the DTCs run continuously. For setting, its ECM receives a glow plug control module serial data message indicating the heater control circuit is open for more than 3 seconds. Okay, that should be a relatively easy test. Action taken commands the engine to operate and reduce engine power mode. That would explain our 55 miles per hour limit right now. The first thing we need to do is get in there and check the resistance of that heater circuit. Actually here we can verify the appropriate scan tool reductant heater 1, 2, or 3 current parameter is within the range specified below by commanding the reductant heater 1, 2, or 3 onto the scan tool. Should be 5 to 7 amps. So I didn't see a test in there for doing that, but maybe it's going to be in the glow plug control module. Let's go and see if we can't find the reductant heater test, and we can test the amperage on that. So that code originates through the glow plug control module. So we're going to go into the glow plug control module and see if we can't get some type of a test out of that. Alright, here. Reductant heater 1. That's our code, is reductant heater 1. Should have 5 to 7 amps. Let's see. Oh, and we do get an amp reading, so let's try and turn that on. Turn it on. We're getting no amps. Off. On. We're getting nothing. So we may have an open on the reductant heater. That would set our code. Let's go into reductant 2, see if we get different results on that here. It's a different heater unit, and it is a different, it would be a different code. So turn on the heater. Okay, see, now we're getting some amperage out of that one. An amp. And it's off. Turn it on. We're getting an amp. Okay, turn it off. Let's check 3. Check 3. Okay, so 3. Let's see what we get for amperage there. Yeah, we're getting 2 amps out of that one. Turn it off. Turn it on. Yeah, so we're getting something out of those ones. Let's go back to heater reductant 1. And okay, we're watching that one there. We got nothing. So that heater's not working. Let's get underneath there and see if we got power and ground. Let's put it up, check underneath to see if we got power and ground to the heater. If we got power and ground to the heater, we probably do a resistance test on the heater itself, and it'll probably going to see that it's open. But we got this one on the run. We can figure it out. So I'm looking for the resistance parameters for those heaters, and all I find is the amperage draw. So using a little Ohm's law, we can figure out what these are supposed to be. So reductant heater 1 is the one that's in question. It's a 5 to 7 amp heater. Let's say 6 amps, make it simple. So if you take 12 volts divided by 6 amps, should be 2 ohm resistor. Reductant heater 2 should be about 1 amp, which would make it a 12 ohm resistor. And reductant heater 3 is 2 amps, which would make it 6 ohms. So I printed out this schematic for the reductant heater glow plug module setup. So here's our setup over here. So the reductant pump, the reductant heater, and the inline heater. There's actually a heater in the pump too, so there's 3 of them. This is the one I believe is in question here, is the actual reductant tank heater. So if you look here, they're all grounded at chassis, and they're all powered by the glow plug control module. Now this connector X395 is above the reductant tank and real difficult to get to. So instead of trying to fight through the mud and dirt and get to that connector, we can go to the glow plug control module. It's on top of the engine. It's a couple things to get out of the way and you can get right to it. Open that connector up and then you can test these circuits there. So I think what we'll do is we'll go to the glow plug control module. We'll unplug that connector and then we can ohm out from pin 1 to ground, pin 11 to ground, and pin 6 to ground, and we should get our readings that we decided on Ohm's law. So let's get to that. Here is the glow plug controller, right down in there. And this is the connector. I already have it off. Typical crusties in there won't let it come loose, but little finagling got it out. The pins for our reductant heaters are going to be 1, 6, and 11. Our pins for our heaters, there's our heater, 1, 2, and 3. Actually, I think it goes 1, 2, and 3. They are pins 1, 6, and 11, and then it grounds, they all ground. So basically if we check resistance from those pins to ground, we'll be able to get a good reading of what we're of the resistance of those heaters. Now, based on our Ohm's law, we know that one of the heaters should have 2 ohms. The one in question has 2 ohms. One should have about 9 to 12 ohms, and then one should have 6 ohms. So let's check our pins and see what we get for resistance on those heaters. Alright, so first one, we've got 6 ohms. Okay, that's what we should have on that one. Next one is we should have, I believe, 9 to 12 ohms. And we got 10 ohms. This last one, this is the one that's in question. This is the Reductant Tank Heater 1. Should be 2 ohms. It's the highest rating one. And we have 188 ohms on that one. That should be 2 ohms. So that's basically an open circuit. The computer's going to look at that reading as basically being an open circuit. So that's pretty conclusive. That thing's going to require a reductant heater. The code that we're getting is a Reductant Heater 1 fault code. And if you read here, the Reductant Heater 1 is in the reductant reservoir, Reductant Heater 2 is in the supply line, and supply line to the injector, and the Reductant 3 is in the pump. So there's 3 heaters there, and you got to make sure you're diagnosing the proper one. The one we have is in the reductant reservoir. It's kind of at the base of the pump housing. You have to replace the housing. You have to replace the pump housing to replace heater 1. So if we come down here to the there's really no resistance specs for this thing, but if we use Ohm's law, we can look here. So they give you an amp rating of each of the different heaters. So if you do Ohm's law and take your 5 to 7 amps, let's call it 6, and divide 12 volts by 6 amps, your Ohm's law tells you that the ohms reading should be 12 divided by 6. On Reductant 2, you should have, if you average that out, probably 1 amp. You'd have 12 ohms on if you wanted to ohm test heater Reductant 2. Reductant Heater 3 is, let's say it's 2 amps, you're going to have a 6 ohm reading. So on what we're looking for is Reductant Heater 1 being about 2 ohms. And if you remember right, on our heater Reductant 1 we got like 188 ohms. I knew that was wrong, but I wanted to show you why I knew that was wrong. So at 6 amps rating, we should see a 2 ohm reading on the heater. So I have the new heater here. Let's take a look and see what we get on that reading. So here's our new part, GM part. I don't recommend you use aftermarket on these, but this is the GM part. These are the level sensors here, and in the bottom of that case here is the heater. So the heater comes up to this connector right here, and I have the multimeter on, and I'm using my leads to connect to the heater connector. Now when I plug this in, we should see 2 ohms on that heater, a healthy heater, exactly 2 ohms. So that's the power of Ohm's law, knowing what you're going to test when you're going to test it. We are replacing this reductant heater, and so we got to get the tank out of there. We've got the hose up there to do. We've got 3 bolts that hold this cover on, and they kind of clip on this side. You can probably see the clips up there. We'll get the tank cover off, we'll get that hose off, and then there are 13mm bolts there and up there, and then those straps just kind of hook in the back. So not sure that I can show you everything on this thing as I do it, but I'll set the camera up and we'll see what happens. He's got the reductant tank full, so it just pissed urea all over me. Pull that this way, obviously. So. I thought I was a lot closer. I got close. There you go. There's a pack full of dirt. Alright, got it running again now. Got it refilled with DEF fluid, cleared the code, and our lights are out. I'll go drive it here, make sure the system stays error free, and then we'll ship it. Thanks for watching.